Hello, so today we are going to do this problem, which is part of Leetcode daily challenge for June, relative sort array. So basically we have an array of numbers. We have array 1 and array 2. And array 2 has the elements of array 2 are distinct, so there are no duplicates. And all the elements in array 2 are also in array 1. Okay. Now what we want to do is sort array 1 such that the relative order of element is the same as array 2. What that means basically is if a number appears first compared to another number in array 1, it should appear first compared to that same other number in array 2. So basically the same order. If we take a look at this example here, the other detail is that if an element is not in array 2, right, because we are guaranteed that array 2 elements are in array 1, but there could be elements in array 1 that are not in array 2. So if an element is in array 1 but not in array 2, we want to just append it to the end, but in ascending order of values. Okay, this is important, in ascending order of values. So if you take a look at this first example, this is array 2, this is array 1, so you can see already 2 is followed by 3, and then followed by 1, and then followed by 3 in array 1. But what we want is the order in array 2, which means 2 followed by 1. So we put all the 2's from array 1 first, and then we put 1 second, and then we need to put 4 second, so we take this 4, put it second. Then we need to put 3 afterwards, so we take all the 3's and put them afterwards. And so you can see, and then 9, same thing, we put the 9 here, 6 here, and then 7 and 19 are not in array 2, so we just put them at the end. Now notice, we did put them in sorted order. Even if we had 19 here and 7 here, we would have put the same order here because we want to put them in sorted order. Okay, so that's the idea. Now how do we do it? Well, the easiest way is to do exactly what we are being asked, right? So which basically means we just take array 1 and we sort it using some key that is checks the index in array 2, right? So we just take that element to check its index in array 2 because that's exactly the place where it should be, and then we add it. But what about the element that are not in array 2? If we do index only, then we'll get an error because we won't be able to find them. In that case, we want to check if an element is present in array 2. So to keep that operation of 1, we will just take a set for array 2 and do this only if the element is in array 2. If it's not, what should we do? Well, if it's not, what should be the order? Well, we know it should be appended to the end of the list. The list is array 1, right? And so we know it should be at the end of the length of array 1, so n. But again, we also want them to be in ascending order, okay? So to do that, let's just have the value be starting from the end, but also plus the value itself so that it can be in ascending order, right? And then at the end, we can just return array 1. Or we can even do this in a better way, which is sorted array 1 like this, and then have that as the key, and then return this. So this looks good. Let's submit. It gets accepted, okay? Now, in terms of time complexity, we have this is O(n). We have the sorting itself, which is O(n) log(n), but the key also is O(n). So it's not very optimal. How can we improve it slightly? We'll still keep sorting, but I want to improve it first with the sorting, and then we can do a different approach. So how do we do that? Well, if you notice here, instead of using this set, what can we do? Well, we can just have first array 2 because we want the index, but then we want the order of the elements, the remaining elements in array 1. So we can just have array 1 sorted and get the index. That way we guarantee that it's in array 1, like this. Okay. Okay, so now we will, if it's in array 2, we'll get the index. If it's not, we'll just have its order in array 1, right? Because we sort array 1, and we will get the index. Okay, you can also, just so that we don't do this twice, we could just have this sorted array 1 like this and have that like this. Okay, I remove this. Okay, so slightly better, still not great, but slightly better. Okay, so how do we do this without, this is still oven again, right? With this and with the index, it's even for every sort operation, it's oven, right? So how can we make this even better? Well, what we can do is, if you notice here, what we are doing is, we know the position of the element. We add all of its occurrences at once, and then we add the next element. We add all of its occurrences, and we keep going like that. So we need to know the number of occurrences for each number in array 1, because array 1 has duplicates. And so we can have a counter to know how many are there. So we have a counter for array 1. And then we can go through the elements of array 2, right? Because remember, those are the elements that we want to sort. Because we want to sort elements of array 1, right? But we want to get, so this gives us the order that we want to follow. So this gives us the order. Gives the order. So now we know this element should be first, each element that we get. And so we just take how many occurrences it has. So let's just have this be like occurrences, right? And we need to have our result array sorted, basically array 2 that we need to return at the end. Sorry, sorted array 1 that we need to return at the end. So let's call this res. Now, if this element in array 2 is in array 1, which means if its occurrence is bigger than 0, then we want to add it, but we want to add it as many times as it occurs. So we want to basically add it, or we can do extend the number of occurrences of that element. But remember, we also want to, once we do this, we want to set it to 0, right? Because we just used it and added it, right? Okay, so now this way we process all the elements and we put them in the right order of array 2 in res. But now we need the elements that are not in array 2. Elements that are not in array 2. Now, one thing here is, we know that we have at most 1,000 elements. So we can just go through all of them. So it's called A in the range of 1,000. We do 1001 just for Python here to stop at 1,000. And now if there is still occurrences, that means it wasn't in array 2. And so if occurrences of A are still bigger than 0, which means it wasn't in array 2, we will go in order also. So this will guarantee the sorted ascending order. And so if it's bigger than 0, then we can do the same thing. Add it as many times as it occurred, and then we do set it to 0. Okay. So now if I run this, should gets accepted. Now in terms of time complexity, this one is a lot better because we are using oven here, n being the length, n2, let's call it, the length of array 2, and then 1001. So n2 multiplied by 1001 is just O of n2. And then we are using extra space here. That's the one sort of downside, which is O of n1 space. And of course, the res is n1 plus n2. So O of n2 time and O of n1 plus n2 space. But definitely better time complexity. And a lot easier also to reason about the time complexity in this case. Now, one thing I want to show, this setting it to 0 and getting the value, this is actually can be done in one operation, which is just pop. So this will pop it and will return the element, or will return the count. So we can use that just to simplify our logic here. And submit. And this gets accepted as well. Okay. Yeah, so I think that's pretty much it for this problem today. Thanks for watching and see you on the next one tomorrow. Bye.